This video is going to be on trig function transformations for sine and cosine. So if we look at the top, we have our transformation. They're called transformation maps. They just have the variables and where they are within the variable, and that tells us what type of transformation they will be. So in this topic, we're looking at A, B, and D. In semester 1 and in algebra 2, I believe, D was usually referred to as K. So for something like the vertex form, you would see HK. K and D are going to have the same effect. They will both be vertical translations. But now for the rest of the year, we will see it written as D. And then A, that's going to be your vertical dilation. And then B is going to be your horizontal dilation. And these will be the same for sine and cosine. They'll actually be the same for all 6 trig expressions as we go forward. So just a quick rundown, the amplitude of a sinusoidal function will be the vertical dilation, and that is going to be your variable A. And that's multiplicative, so you'll see it multiplied with the trig expression. The midline of a sinusoidal function is simply a vertical translation. That will be D. So just to recall, your vertical dilation will be, in algebra 2, you call that a stretch or a compression. But in AP pre-calculus, we just call it a vertical dilation, and then we refer to the scale factor to determine if it's a stretch or a compression. But we'll still say stretch compression just to make sure that we can visualize it. And then for a vertical dilation, that's going to be up or down. So both of these, your A and your D, they will affect your Y values. So they are changing the Y values. These will also affect, we're going to talk about range for all of the trig expressions, so they also affect your range. And then at the bottom, the period of a sinusoidal function is the result of a horizontal dilation. That's going to be your variable B. So again, it determines a stretch or compression horizontally, which that's going to change your x values. So it's changing x values. And these will also, this will also affect your domain. So we talked about domain restrictions for the trig expressions that have vertical asymptotes. Your vertical dilation will also change those. So pushing them to the left or to the right, or I'm sorry, not pushing them, but stretching them outwards or compressing them inwards. We'll talk about shifting them left and right. And then over here, it's just another review for the translations that we're going to be looking at in this topic. And then don't forget, for a period of a function, the period will not be the same as the B value. Okay, so the P represents the new period. The B is the variable that you place within your function. And then we also talked about in class how you can find the new or the B value by using the ratio of the periods, old over new. And we'll talk about that several times. So the first question is, the graph of the sinusoidal function h is shown in the figure to the right, along with information about the amplitude, midline, and period of the graph. The function h can be written as h theta equals a sine b theta plus d. Find the values of the constants a, b, and d. So my suggestion, especially on the exam, don't do more than you're asked to do. They're not even asking you to write the function. They're just saying find a, b, and d. Or I guess I'm saying find a, b, and d. And because it's the first one, there's all of the information is in the sketch. So the amplitude, that's going to be your distance from your midline, which is here, slicing the sinusoidal curve in half, to the relative extrema. So either to the maximum or to the minimum. And then remember, your amplitude is always positive, right? It's a distance. It's the distance from the midline to your maximum. And then we do have a little formula for that. You can use it if you need to, but it's never required, right? And then I'm going to abbreviate amplitude using amp. So the little formula is max minus min divided by 2. So we're taking the distance between the maximum and the minimum, and then we're slicing it in half or dividing it by 2. So in this case, the maximum is 9, the minimum is -3. So we'll have 9 minus -3. Divided by 2, that gives us 12 over 2, which is 6. Therefore, A is equal to 6. Now, we had a discussion about this in class. Your amplitude cannot be negative. However, if you're asked for the a value and then if you're creating a function rule for a particular graph or a verbal statement, a table, anything, a can be positive or negative as the variable. However, when we're specifically talking about amplitude, it will be positive. This is a sine graph. They tell us that because we can see that it aligns with the parent function sine theta, and they tell us that we are using the parent function sine. So a will be positive for this one. The next variable is going to be our b value, and this is going to be the variable that we use to determine the horizontal cycle relationship of this sinusoidal curve as it compares to the original sinusoidal curve. So this one has a period of, they tell us it's p equals pi, all right? All sinusoidal curves have a period of 2 pi. Whether it's cosine or sine, it's always 2 pi. So we can use that relationship in order to find the b value. So in class, we've been using, we'll go ahead and write the period for this. In class, to find this variable, we do b is equal to old over new. And then it's just a rewrite of what College Board uses. New period equals the absolute value of 2 pi over b. All I did was switch the b and the p, so we get 2 pi over p, which is old period over new period. So whichever is easiest for you, just be consistent in what you use. I'm not requiring you to use either one. You don't even have to show work for this if you can see that this period is half of the original. Therefore, your b value should be the reciprocal of that, which is 2. But if you need to do the ratio, old period is 2 pi, and then the new period is pi. Therefore, we end up with 2 as our b. So again, we use the reciprocal, it's flipped, because it's a horizontal dilation, just like we did in our parent functions in semester 1. So I had questions, why does this happen? Why are we flipping? Why are the x values either flipping or they're opposite? Well, if you think about it, if we look at this, our a and d value, they are multiplicative and additive on the outside, all right? They are not affected by what sine is doing, all right? They are changing sign. However, when you have items on the inside here, like b and c, we are doing two things. They are affecting the input, and then we also have them affecting the output. So we're essentially undoing what it's doing in the input because we're using it twice. And I'm saying that it's hard to not go back on those words, but your input values, it's on the inside of this function, the parent function, but then we also have to apply it to the outputs, all right? So it's kind of like you're undoing what's happening on the inside in order to see what's happening to the actual function. And then if that statement is completely false, then I'll fix the video or add a comment down below. So for D, we're looking for the midline. The midline, graphically, it's going to be pretty easy to find. In this case, it's going to be 3. Most of the time, it'll actually be labeled as a dashed line. It looks like a horizontal asymptote. But for the midline, we also have a formula for this one. It's max plus min. Again, you are not required to use this, but on a rainy day, if you can't remember, you can always just use it. The maximum is 9. The minimum is going to be -3. So looking at the graph, I should get 3. So I get 6 over 2, which is equal to 3, which is our D value. All right, so example 22, the figure to the right shows the graph of a trigonometric function f. Write an expression for f theta. So now we just have this curve. They did not give us the midline, and there's no other information given other than the intervals for the outputs, and then the intervals for the inputs, all right? And they'll always be equal length input value intervals. So think of that once we get to sketching in the future. All right, so when it says write an expression, that means we need to find the 3 variables a, b, d. That's the focus for this topic, is just a, b, d. And if you notice, if you think about sine and what it does at the origin, it crosses through the y-axis and it's increasing. Okay, this is very important to recognize. So on the y-axis for the parent function of sine, sine is crossing the midline and the y-axis as it's increasing, okay? And we can see that relationship here as well, but instead of it going through the origin, we can see that it was pulled upward by 3 units, okay? And that is where your midline will be. You can find your midline just by looking at the sinusoidal curve and then slicing it directly in half, right? And that will be your D value as well. So I know that based on what's happening at the y-axis, that this will be I can use sine for this. So maybe I'll notate that. F of theta, we will be using sine theta, because I can see that it's crossing the y-axis through the midline and it's increasing. So we'll do A, we'll have B, and then we'll have D. So again, we have that formula for D, but graphically you can just look for it. So with this one, we're shifted up 3 units, therefore D is equal to 3. Once you have the midline, the amplitude is pretty straightforward. Just look for a minimum or maximum that's nearby and look for the distance in between the midline and the amplitude. So I can see that my midline is at 3, and then, and the maximum, between the midline and the maximum. So I can see that my midline is 3, the maximum is at 6, therefore my A value is going to be 3. And then the B value, that's going to tell us about the period for this function. So again, we're going to use old over new. The old period for any sinusoidal curve, whether it's sine or cosine, think of the unit circle, will be 2 pi. So now we just need the new period. So you can use any part of a sinusoidal curve. As soon as you see that part repeat, that's the start of a new cycle. Usually I say use the maximums because they're unique attributes that they stick out pretty prominently. So I'm looking here to here. But then that's the question of, okay, that's not specifically marked here. I could find it if I wanted to, but understanding how to find periods using different parts of the graph are going to benefit you anyway. If we look at if we look at 0 here, we see that we are increasing through the midline, okay? Which means the next time I see this happen again, that's going to be the start of a new cycle because that's the end of the one I'm currently in. So with this one, I'm increasing through a maximum, and now I'm passing my midline again, but I'm now decreasing through that midline, all right? So it's not the same event as what occurred at 0. At pi over 2, we are decreasing. So that means I'm going to continue through, and now I see that event occur again here. So at 0 and at pi, I see the same event occurring. We're passing through the midline, and it's increasing. Therefore, the period for this sinusoidal curve is going to be pi. It took a pi before I saw the same event occur again. So my new period is pi, therefore we'll have 2 pi over pi, which is equal to 2 again. Now this one says write an expression, so we can't just leave ABD like we did up here. We need to write an actual expression, and they want us to label that expression as f of theta. All right, so don't just write f of x or anything that you want. Follow the context of the problem. So f of theta is equal to, our A value is 3, our B value is 2, and then plus 3. And with this one, you can use parentheses. They're not required, but sometimes it makes it more obvious what's going to be the input. All right, the figure to the right shows the graph of a sinusoidal function g. What are the values of the period and the amplitude of g? So now this one is not asking for an expression, it's just asking for the period and the amplitude. So be careful, we're not looking for b. We're not looking for that. The period and the b value are not the same thing. They work together to solve for one another, but make sure if it's asking for the period, you explicitly state what the period is. Let's do the amplitude first. So with this one, the midline was not given, but if I look, I have a maximum at 1, and then I have a minimum at 3. So that's going to give me a total distance of 4. So if I slice that in half, I count down 2. That's where my midline is going to be. Or you can use the formula as well. But I would just say if you have a graph, take advantage of that, just you can use the grid that's provided so that you can see where the midline is going to be. So if I look at this, my midline is going to be at -1, which means I can use this to find my amplitude, so the distance from the midline to the maximum, or I can just use what I had here. It took me 2 units to get from the maximum to the midline, so that's what my amplitude will be. So the amplitude is 2. So I talked about A being positive and negative. We're not solving for A, we're solving for the actual amplitude, which is distance. So if you were to write -2 because you use that minimum here, that would be incorrect because amplitude is a distance. It cannot be negative. All right, the period. So now same thing. I can see that the maximum, it's splitting the ticks, which from 0 to pi over 2, if we split that in half, we end up with, this will be -pi/4, and then over here, this would be 3 pi/4, if you were to use the maximums. Or you can start here, we're at -pi, and I see that we are starting this cycle, we're passing through the midline, but instead of increasing, we're now decreasing. So I want to see when does that event occur again. So I'm finding the minimum, passing the midline, but I'm now increasing. That's not the same as this. These are 2 different events. So that means I'm not done with my cycle. So I'm going through the max, and then here, I'm passing through the midline, just like I did before, and it's decreasing again. So that means we're going from -pi to 0, which is a period of pi. So the period for this is pi. And then I apologize again, I'm a little sniffly. I'll try to keep it to a minimum. So example 24, the trigonometric function k has a maximum at point 0.06. After this maximum, the next minimum occurs at point pi/2 -4. Which of the following could be an expression for k of x? So the multiple choice, it's a game. You're going to be given a lot of information that isn't going to be very useful. So if we look at this, all of these are cosine, and then my midline, they're all 1. That means I have information. I know that this is going to be a cosine, a sinusoidal curve written as cosine, and that the midline is going to be at 1. So use that to your advantage. We also know that there's a maximum at 0.6 and that there's a minimum at pi/2 -4. So my suggestion for these statements is to draw a quick sketch. So we're going to be at 0.6, there will be a point, and then at pi/2 -4. So let me raise, there we go. Doesn't have to be perfectly to scale, but it does help to get as close as possible. Okay, so we're at 0.6, and then pi/2 -4, and it's sinusoidal, so we should see a point of inflection in there somewhere. There we go. And we're going from max to min. So if we zoom in on this, like I said, we already know that our midline is going to be at +1 because of that vertical translation of +1. So I'm going to go ahead and notate that on my graph. So here's the midline. All right, so now that I have my midline, the differences within my choices are going to be the amplitude and the b value, all right, or the a value and the b value. So this is common. We see 10 and 5. If we look at this, the total distance from the maximum to the minimum is going to be 10. But for the amplitude, it's the distance from the midline to the relative extrema. Okay, so we only want this here, which that's going to be 5. So just based on that, I can go ahead and cross out A and B because they have 10. So now I've raised my chances of getting the correct solution. The next thing that we need to look at is the B value, and to get the B value, we need the periods. Well, the old period and the new period. So B is equal to old over new, out with the old, in with the new. Old period is going to be 2 pi. Now, if we look at this sketch, a full period for a cycle will be from maximum to maximum, minimum to minimum, or any event that we see occurs again, okay? So I see this maximum, but I don't see it again within our sketch because we didn't get that information. However, maximum to minimum is going to be 1/2 of your period. Okay, so we're going from 0 to pi over 2, which means my new period will be twice that, which is pi. So again, we'll have a new period of pi, which means b is equal to 2. So something else I want to touch on real quick is if your inputs are in radians or have a pi, your b value should not have a pi. This will not happen. So if you have a pi in your b value, that means the sketch will not be in radians. It will not have a pi for your inputs. And that's because we're taking the ratio. They will always cancel out. Okay? So if your new trig expression is in radians, that means your input will not be in radians. So based on that, that answer would have also been D. And if you don't remember that, it's okay. Like, you can always use this formula. I mean, you have to remember something. You can either remember that, but you will need to remember this because we use that to find B and the new period. Example 25, the trig function f is given by f of x equals 3 sine of 2x minus 1. Which of the following could be the graph of f of x? All right, so we're given three things. We know that a is equal to 3. That's our amplitude. Our midline is at -1. And then our b value is equal to 2. So because our b value does not have a pi or is not in radians, that means my inputs should be in radians, which I think they all are. They wouldn't make it that obvious. Yeah, so. All right, let's look at the midline first. That's usually that's an attribute that can stick out pretty easily on the y-axis. This a has a midline at +1, therefore it will not be a. B has a midline at -1, -1, -1. And I know that on the y-axis, that's the midline because it told us it's sine. So I should see it increasing through the y-axis and the midline. All right, so we did all we could with the D value. Now let's look at the amplitude. So if we look at the amplitude for B, we go up 1, 2, 3. All right, so that's an amplitude of 3. For this one, we go up 1, 2, 3. C has an amplitude of 3. D, 1, 2, 3. Okay, that did not do anything for us. So now we have to rely on the B value. So again, the B value is not the period. It's the ratio of the old and the new period. So we'll have B is old over new. I want to find the new period, which AP Classroom, you'll see it as P. So my B value is 2. The old period is 2 pi, and then I want to find P. So if I switch these two, I get P is equal to 2 pi over 2, which means we get pi. So that means the new period is a length of pi. So that means I should see the same event occur a pi later. So we'll start with this one. So it's increasing through the midline. I see this event occur here at 2 pi, which is twice as big as the new period that we want. So that's not going to work. Let's try C. So again, looking for that sinusoidal curve crossing through the midline, increasing, I'm going up, decreasing, and up. All right, so I see this event occur a pi later. So it should be C, but I just want to look at D just to make sure. Leave no stone unturned. All right, for D, we see this event occur on the y-axis, and then it occurs again at pi over 2. Okay, so it's not D. So the correct answer is C. All right, this is on the phase shift. I think that's yeah. All right, so this is on, there's a couple things on phase shifting. Phase shift is going to be, it's the same as a horizontal shift. I think they already wrote that, yeah, or a horizontal translation. So this is going to be your left to right. And it's going to have the same effect that it did with your parent functions in Algebra 2 and in previous semester. Don't get confused by this. It says x plus c. our C value will still be negative C units, all right? So we'll talk about it. We'll talk about flipping it once we do some examples, okay? So the figure above shows the graph of a trig function g. Which of the following could be an expression? All right, so in this one, we have a couple options. Well, we have 4 options. And we have to choose between sine and cosine. And then we have our A, we have a C, and we have a D. So there's a couple ways to approach these. You can find your A, C, and your D based on the sketch, and then you can eliminate your choices from there, or we can walk through each multiple choice and see what happens, okay? Now, if we look at this, the amplitude, or the A value, is the same for all 3. So that finding the amplitude is kind of useless because they're all already 3. We also see that they all have the same vertical translation, 1 unit down. So that's going to be the same as well. I mean, I can notate that. That'll help. Because the main difference that I'm seeing in this one is what's happening with our inputs. Okay, now we don't have a B value. Well, the B value is 1, which means my period should be 2 pi. Because the sinusoidal curve has not been compressed or stretched horizontally. Because that B value is equal to 1. So -1, 3. So the question is the shift. What is the phase shift for this? And that's going to depend on, okay, are we looking for cosine or are we looking for sine? All right. And then now we also introduce these reflections here. That's going to change what we're looking at. So to determine what function you're using, you have to zoom in to the y-axis. And you have to think about your parent functions, all right, for cosine and sine. So cosine increases through the y-axis. The parent function does. While cosine hits a maximum. So this is what we're looking at. But this is positive sine, and this is positive cosine. So let's take a look at what would happen if we were to apply a negative to those, because now we're going to start getting into negatives. So if we think about sine, if we were to vertically reflect this and say that we have negative sine x, that's going to flip the concavities, and it's going to change whether it's increasing or decreasing. So instead of concave up here, we're now going to be concave down, and it's going to be decreasing through the y-axis. Same thing for cosine. Instead of a maximum being on the y-axis, we will have the minimum on the y-axis. So it'll look like this. So this is when it gets a little tricky, because before we just had, oh, it's either sine or cosine, but now you're going to be pigeonholed, oh, it might be negative sine or it might be negative cosine. So let's check out the 4 choices. So part A, or choice A, says cosine of 3 cosine x minus 1. 3 cosine x minus 1. So if we think about that, this parent function is positive cosine. So what I want to see is that maximum on the y-axis, because this is technically x plus 0. We didn't shift off of the y-axis, so this is telling me that if I were to look at the y-axis, then there should be a maximum because this function is positive cosine. I do not see a maximum here, all right? So that means this choice is false. I see a minimum, but to use that minimum, it would have to be -3 cosine, all right? With that negative showing that vertical reflection. So the answer is not A. So now let's look at B. So now I do see that -3 cosine, all right? So I want to focus on the minimum and see where it is in relation to the y-axis. But the issue is, if I were to use -3 cosine, it's on the y-axis, which means there should be no phase shift or no horizontal translation. But in B, there is one. This is telling me that the minimum was shifted off of the y-axis by pi. So if I go to pi, there's nothing there. There's a maximum, but my minimum was not shifted off of the y-axis. Therefore, that phase shift should not be in there. okay? If this was negative 3 cosine x minus 1, where there was no phase shift, this would work, but that's not the case. And then now let's look at C. So now we're not looking at the extrema anymore. We're looking at when the function is specifically increasing through the midline, because this is positive sine, okay? So remember, the parent function for positive sine, it passes through the origin increasing. So let's check for this one. So if we look at when this function is passing the midline and it's increasing, we can see it at pi over 2, 5 pi over 2, and then so on and so forth. All right, so it's increasing through the midline. So now if I look at my phase shift, this is telling me we should see one of those using x plus pi over 2, which means this is shifted left by pi over 2. So remember, we're going to flip those signs because they're the inputs. Whatever affects the domain or the x values, it's going to be plus or minus, or you're going to reciprocate. So now if we look at this graph, if I go off of the y-axis by pi over 2, I do see this event occur, right? The function is increasing through the midline, so therefore C is going to be the correct answer. For D, the negative and the sine, you would want to use this event here. So when the curve is decreasing through the midline, and then you would see how far that shifted off of the y-axis. All right, next one. So the figure above shows the graph of a trigonometric function h. Which of the following could be an expression? So same thing. See what's different, see what's the same, so that you know what to look for. In this one, our amplitude, or our a value, is 2. All right, so we don't really need to focus on that. Same with the midline. It's all plus 1. Okay, and then luckily, our b value is 2 for all of them, which means if b is equal to 2, that means we have a horizontal dilation with a scale factor of 1/2. So we are compressing this by 1/2 from its original function. So the two things that we are looking at is, are we using cosine or sine? And then what is the phase shift? All right, what is the phase shift? Okay, so for cosine, think of your, well, it's specifically positive cosine x. Think of your parent function. If you don't know your parent functions, this whole rest of the year is going to be a real struggle for you, okay? So if I think of cosine, I have that maximum on the y-axis, okay? So I'm going to look for the maximum, okay, and see what that does. So if we start with this one is telling me that for positive cosine, so we're looking for the max, that it is shifted off of the y-axis by pi over 4, right? So this is a shift right by pi over 4. So in the positive direction, because we want to switch it. So if I go back to here, I see this maximum here, okay? But based on what A is telling me, it should have been shifted off of the y-axis by pi over 4. That is not happening, okay? My maximum is at pi over 2, not pi over 4. So that means A is incorrect. So for B, we're still working with that positive cosine, so we're looking for the maximum. But now this one is telling me that it's shifted off of the y-axis by a pi. So if I look up here, I have my maximum. So again, we already established that it's at pi over 2. B is telling me that my maximum should be out here. There is no maximum here. There's a minimum, but that would be for negative cosine x, because that would reflect our parent function. So therefore, B is not the correct answer either. So now let's flip over to C. That means we have to change our mindset. So now we're looking at positive sine x, which means, okay, I want to see when does our sinusoidal curve increase through the midline. All right, so this is what I'm looking for. I want to see when does it increase through the midline. So based on the choices that we're given, our midline is going to be at 1. So we can use that to our advantage, easier to see. So that C, this is telling us that the sinusoidal curve is passing, or it's increasing through the midline at pi over 4. positive pi over 4. So if I look at this, I see that that event is occurring here, and that is going to be at pi over 4, okay? And I know it's pi over 4 because these are equal length input value intervals, which means if we slice that directly in half, it will be pi over 4. So this one is going to be C. D says that this event should occur at pi, which it's not, because we labeled that as negative cosine because that's a minimum. So we know D is not the correct answer either. The graph of H and its dashed midline for 2 full cycles is shown above. 5 points are labeled on the graph. No scale indicated and no axis are presented. The coordinates of the 5 points are F is 216, G is 511, J is 86, K is 1111, P is 1416. The function can be written as h of t is equal to, they're using sine, that's important. So this says find the values of constants A, B, C, and D. Okay, so my first suggestion for these, this is leading us into one of your FRQs that you will see in May, right? It's always no scale indicated, no axes are presented, but you'll end up with these coordinate points where you can see your maximums, your minimums, and you can find your midlines and your A, B, C, and D from that as well. So if we look at these, F is going to be at 216, so the maximum's at 16. G is at 511, so the midline is 11. And then J, our minimum, will be at 86. And then K is going to be at 1111, and then P is going to be at 1416. All right, so it's not asking us to write an expression. We just need to find our ABCs. All right, for this one, I typically start with the midline because it's going to be given to you. So the midline is going to be in the middle, which means D is equal to 11. And then from there, by extension, we can find the amplitude. So the midline to F, which is our maximum, that's going to be 16 minus 11, just that distance, so we end up with 5. So your A value is going to be 5. Now, I'll just stop there. Yes, we have to use 5, okay. All right, next let's talk about the B value. Because the phase shift is going to go back to what we talked about in our previous 2 examples, but the B value is just old over new. Now, if we look at this, our inputs are not in radians. That means your B value should be. You should have a pi in your B value because this is unitless. It's not like inches or time or anything like that, but we should end up with a pi in our B value because I don't see a pi in my inputs. The old period for all sinusoidal curves is 2 pi, and then the new period for this I can use from F to P. They're both maximums, so that is an event occurring again, which marks the new start of a cycle. So I'm going from 2 to 14, therefore my period is 12. So the new period is 12, which means we end up with pi over 6 as our B value. For C, so your phase shift, there's an infinite number of solutions for these, okay? But my suggestion is to use a point that was given to you, because then you're not raising the chances of algebraic manipulation errors and so forth, okay? So for positive sine, if you think about your sine function, I want to know when does this increase through the midline? That's going to be my phase shift. So if I look at the start of this, I can see that there's one here, but it wasn't a given point. Could we figure it out based on the period? Absolutely. But if I cycle through my 5 points here, I can see that at K, our sinusoidal curve is increasing through the midline, okay? That means I can use that value, 11. So that means my C value will be equal to 11. All right, the next video will be on tangent. Hope this was helpful.